So we have seen how to implement a linked list, right? Using pointers, we know how to implement linked list. Now we are going to implement a tree, and as we had explained, a tree is a non-linear data structure. So you need to have an above-below relationship. In the screen, you can see an example implementation of a tree. Okay, so this is a tree which contains integers. Each of the node or a vertex in a tree contains integers. Right? So if you had a tree of strings or letters, you could replace these integers, these numbers by those data type. For the example purpose, let's look at a tree of integers. So the tree, each node or a vertex in a tree consists of two parts. One is the integer, which you can see here in the topmost node, the root node, the integer is 25, and the second part of the node is a pointer to a list of children. As we said, a tree can have multiple children, and this points to this list of all its children. Now you can also, if you are considering ordered trees, this could be the ordering of this list also matters. If you are looking at ordered trees, then ordering of this list also matters, in the sense that the leftmost child might be, let's say, the eldest child, and the rightmost child might be the youngest child. Okay, that's an interpretation one has to give to this list. Now, as we said, so we have a list of children, and again each child also has two parts. One, the integer, the value of the vertex, the value in the vertex, and second, the second part is the pointer to a list of its children. So this 70 points to a list of its children, 100 points to a list of its children, and the pointer besides 120 points to a list of its children. It's clear? This is one way to represent trees, and in fact here it's ordered trees. Let's look at another, as you could notice, in this tree the parent information is not stored directly. So if you are at, let's say, if you are at the node or vertex 70, you don't know what its parent is. In many applications, when you are at a node, you also require to know its parent, right? So if you want to implement such applications, you would also require a node to also store the parent information. So let's modify this tree to also include the parent information. Now we have also included the parent information in a node or a vertex of a tree. So now a vertex of a tree has three different types of data. One is the value which is stored in the node, and here it's integers, and the second is a pointer to a list of children, and third is a pointer to a parent, right? So if there is no parent, or in the root, what should be the parent value be? This is null, right? If there is no parent, this should be null. On the other hand, the node 70, its parent node is pointing to its parent pointer, points towards the node 25. Similarly, the node 100, its parent pointer also points to 25. 120, its parent pointer also points to 25. Okay. It's clear. Now, what happens if a child, if a vertex has no children, or if a vertex is the leaf, in that case, this that pointer to its children, that particular pointer is made null. It's clear? So if I look, so now given a node, I can tell, how can I tell whether that node is a leaf or not? Okay, so if given a node, that is this much information, right? Given a node, how to tell if it is a child, all I have to see is its child pointer, right? If the child pointer is null, it means that it does not have any children, therefore it's a leaf. On the other hand, if I want to know if it's a root or not, what should I do? I look at its parent pointer and I see the parent pointer. If the parent pointer is null, I can say it's a root. How can I tell whether it's an internal node? To tell whether it's an internal node, I have to check whether I have to check the children list, and if that list is not null, or that pointer is pointing to some list of children, then again it's an internal node. It's not an external node, or it's not a leaf. Clear? Now given a node, I know how to find whether it's a leaf or a parent or a root, etc. Secondly, I can also now traverse. Given a node, I can traverse to its parent. How can I traverse to its parent? I take the pointer to a parent node and I go up. I can traverse up. I can also traverse through its children. I can go to the child, the list of childs, and I can go to the first child or the second child, etc. And I can traverse that children, right? Lot of questions come, right? As soon as I talk about traversing, you should ask in your mind a lot of questions. I give you a node. Can I print the path to its root? The path to root, as we said, the path to root is unique. Can I find a path to its root? Can I print that path? Is there an algorithm to do it? Next question, I give you a node. Can you write an algorithm which prints all its children? Okay. And which order? Can I print all its children in the left to right order? So all these questions can be asked now. You can also think about algorithms to write, programs to write all these things.